In this video, I'm going to talk just a quick review of interval and radius of convergence. So you can see I've got 2 to the k over 5 to the k times x to the k. So certainly a geometric series. With this, I could write as 2/5 to the k if I wanted to, and x to the k. But let's start with our ratio test. So to begin with, we always want, of course, the next term. So we're going to have 2 to the k plus 1 over 5 to the k plus 1 times x to the k plus 1. Now, normally, of course, I would divide by the, and I could write, divided by 2 to the k over 5 to the k times x to the k. And maybe I could do a little simplifying right away. For example, x to the k plus 1 over x to the k just leaves us with an x. Now, things with an x, we like to just pull out front. I'm going to wait just a second and also evaluate the and simplify the rest. So this will become I'm going to put the x up front. I've got 2 to the k plus 1 over 5 to the k plus 1 multiplied by the reciprocal, which would be 5 to the k, and 2 to the k. So this and that divide out. This and that divide out. So I have 2/5 x. Okay. Now I like to pull everything out that isn't immediately attached to in this case, a k. I'm going to pull those out front. So now I have 2/5 x times the limit as k approaches infinity of just 1. And remember, I need this to be less than 1. That's the whole point of ratio test, is I need my answer to be less than 1. Well, the limit as k approaches infinity of 1 is just 1. Okay, so I end up with 2/5 x has to be less than 1. Now, you need to, at this point, kind of recognize the fact that it could have been an alternating series. So instead of just saying 2/5 x has to be less than 1, we should say that 2/5 x has to be between -1 and 1. And if we multiply both sides by 5/2, we have that x is between -5/2 and +5/2. Okay. Now, we always need to check the endpoints. Okay, that's kind of one of the things that maybe makes a little more work here at the end. So we go back to our original series. Let me kind of box this in, and we check the endpoints. We say if I plugged in -5/2 for x, let's do that. So we'd have 2 to the k and 5 to the k times a -5/2 to the k. Okay, well, if you look at this, I mean, it's all to the k, so we can kind of multiply it out, and we would have -10 over +10 raised to the k. This would end up as -1 raised to the k power. Well, that diverges. Okay, that just alternates between -1 and 1, which that doesn't converge. So then we check the other endpoint. We say, okay, well, what if I plugged in +5/2 for x? And I think you can spot pretty quick, 2 to the k times 5 to the k over 5 to the k times 2 to the k. In this case, I get 1 to the k power, which definitely diverges as well. So this is my interval of convergence. We stretch from -5/2 to +5/2. Now, that's a width from -2.5 to +2.5. That's a width of 5. So my radius of convergence, remember, is always the width divided by 2. So my radius of convergence would just be 2.5 or 5 halves. Okay, so the interval actually tells all the values. The radius just says how wide is that interval. So again, we always start with ratio test. We simplify best we can. I pull out everything that doesn't have, in this case, a k. Of course, usually it's n, but I pull that out, and I ended up then with nothing left in there. So I just had the limit as k approaches infinity of 1. Well, the limit of 1 is 1. So I had 2/5 x multiplied by this limit had to be less than 1. And remember, the reason you put less than 1 is because you're trying to make it converge. You're using ratio test and you need it to converge. Well, to converge, a ratio test needs to come out less than 1. We put it between -1 and +1 to account for the fact that it could have been an alternating series. So 2/5 x has to be less than 1, but also could be greater than -1. I multiplied both sides by 5 halves. Then you check the endpoints. You plug it. You go back to the original. You plug -5 halves in for x. We found out that diverged. Then we plug in 5 halves for x, and we found out that that diverged. If it would converge, then of course we'd add the equal sign. It could be less than equal to, greater than equal to, but in this case it didn't. So we're done.